I'm software engineer at Hortonworks. Currently mainly work on the Apache Spark and Hadoop. Active contributor to Spark, Zhang, HBase, and Spaggiari. My experience is mainly on computer networks, distributed system, and machine learning platform. Okay, thank you.
Okay, next slide. It works. Okay. Can you hear me? Yes, perfect. So I am Jean-Marc Spaggiari. I stand by GMS. So it's perfect for someone in Java to be called GMS. I love it. Thanks for that. I'm a solution architect at Cloudera. I have done almost everything. I've been a developer, I've been a project manager, a team manager, but it's boring. So I moved back to something technical. Author at O'Reilly, architecting HBase application. There is a book signing at 7 p.m. at the Cloudera booth if you want to have a free version of the early release of the book. International, I don't have a French accent. It's not what you think, it's just your ears. I'm born in France, I live in Quebec, I work in the US, I'm a Canadian citizen, I work from Los Angeles to Paris. So I have seen many HBase use cases, more than 100 flights last year, so I'm all over the place, and HBase contributor. Also, I've done one patch on Phoenix and a few others. And Ted?
Hello? All right. I don't have a mic, so I have to use this. So wait, you double-click me.
Yes.
Hi, my name is Ted Malaska. I'm a field guy. I'm not actually an engineer on HBase. I'm in the field. I'm an engineer in the field. I've been doing Hadoop and related technologies for over 6 years. I've contributed to a whole bunch of projects, but I'm not a committer on any of them. And this is just because there's bugs that I need to fix to get my job done, essentially. I co-wrote this book here that talks about the ecosystem as a whole, and there's lots of HBase in there. And like Jean-Marc, I've been around a little bit, worked for about 100 companies in about 8 countries. So I'm going to start this off. So in this presentation, we're going to talk a little bit about, where we came from with this Spark and HBase integration. We're going to give you some examples of how to use the APIs and what's coming up. And if we finish quickly, too fast, we'll talk about a Spark streaming use case where you can get exactly once counting, so you don't have to do Lambda if you don't want to. All right, so how did this all start? So I work in the field, right? And sometimes I need things that don't already exist. So the use cases that I ran across, there's 2 really big HBase use cases that I've been doing recently. One is storing every stock transaction that's ever happened in the history of the world, which is about 10 billion transactions every day. And you can imagine it gets very, very big. And it was previously built on using MapReduce and to do a whole bunch of graph-related analytics and stuff like that. And we wanted to switch that over to Spark. Looking at everything that we needed, to be able to do in parallel all the gets, puts, and scans. We needed to be able to do, massive scans just like we did in, when I put scans in that top one, I talk about micro scans. If you're familiar with this, there's table scans and then there's micro scans, just like small ranges. We would need to also do the massive scans. We need to also be able to do bulk load, and then we also need to be able to do gets and puts at any logical place in Spark if we needed to make decisions, right? And another reason why I had to go about this journey is I had another customer that's a medical customer that stores every single person in the United States, every medicine you've ever had, every doctor visit you've ever had, even every color of Jell-O that you've ever had in the hospital if you've gone to the hospital. And what they do is they use HBase as an entity-centric, time-centric data store so they can pull up your entire history to the nurse that's treating you in triage so they can see everything about you in milliseconds, right? But there's one catch. When I went there, the architect of the company said, I will not allow you to use any MapReduce on my cluster, like 0 MapReduce. So that's how this kind of all started. And then the other one is just the advent of streaming and the IoT and the excitement that's around Spark streaming. And we'll talk about it if we get to it, but with Spark streaming, since it has its own internal store with update state by key, you can interact with HBase with puts as opposed to using, increments, which allows you not to do the double counting if you configure it correctly. So it's pretty exciting. So how did it all start? So I wrote this really quick GitHub project. It was just called Spark on HBase. And for a while, that was fine. And Cloudera was fine supporting my customers as long as I was able to take the support calls at any time at night. So I was supporting multiple customers as a field agent. And then Andrew emailed me at one point and just said, why don't we put this into HBase? This makes a lot of sense. Cassandra has integration with Spark. And as MapReduce is phasing out, we have some dependencies on MapReduce. Maybe we shouldn't have all these dependencies on MapReduce. So with that kind of started the journey. And in the beginning, it was really helpful to have Sean, John, Ted Yu, and Matteo as help. As I said, I'm not a committer on HBase, so I needed a lot of help from committers to get in. It was a fairly large amount of code to replace everything that build everything that we did. And the technology, and you'll see through the APIs, support anything you're doing with normal Spark, right? So you can do map functions for each functions, and you get full access to the HBase connection. You can do anything in Spark streaming. So anywhere in the Spark streaming process, you have full access to do anything you want with HBase. And then we have two modes of bulk load that you'll see. One is for really wide tables. One is for shorter tables. And last but not least, we have our first iteration of Spark SQL. So you can interact with HBase with regular SQL statements and even be able to interact with HBase and maybe HDFS or something else as if just with plain SQL. So you can do the joins and stuff like that. And it doesn't have to, your developers don't have to know that they're actually interacting with HBase. And this is my last slide. So underneath the hood, this is the basic of how it works. There's a lot on top of this, but this is the absolute basics of what's going on. There's a driver in Spark, and the driver is like the brains of a Spark application. There's n number of executors that work across your entire cluster, but there's this driver, and this is normally responsible for putting together your DAG, the logic of your code and stuff like that. And what would happen in the driver is you establish your configuration and what HBase server or cluster you want to connect to. And what happens is we distribute that connection information and your credential information to the executors. The executors then store this connection information in a static location so that even on a single executor that can have many tasks that are running in parallel, they're all sharing the same HBase configuration information and HBase connection. So we don't have to keep making a connection every time you go through a different partition or a different task. And this stays live so that when you're doing things like Spark streaming and you're doing multiple steps in a DAG and even repeating over a DAG over and over and over, your connection is staying live, so there's no kind of relog in or reconnect or anything like that. So you can have very good throughput. So that's, I think I'm good on time. So that's my part, and this is Jean-Marc.
Yep, thanks, Ted. So this is what happened when you share your presentation with someone. This was supposed to be my first slide, not his last slide. So I have nothing else to add into this slide. Thanks, Ted, for covering that. But now I will be short on my time, but it's OK. Before I go to the examples, I want to know in the room here if you are already familiar with Spark. Not Spark and HBase, but who has already implemented something in Spark? OK, it's not that bad. So let's start with the beginning. And I will go through a few examples. So Ted explained that we have bulk load and many things that we have implemented in Spark, and I will show you how we did that. If you have already done anything in HBase with the HBase client, this will be very familiar for you. First thing we do, we get the configuration, nothing new here. Then we add the different resources if they are not in the class path, nothing new here. Most of the time, you can just omit that and just the magic line here. Very, very simple. You would just instantiate a new HBaseContext where you give the Spark context and the configuration, and job is done. then now you have your HBaseContext and you can do all the HBase operations. So as you can see, it's very, very simple. Behind the scene, it's not simple, but for the end user on the API side, it's very simple. This is just a RDD just to use in the next examples. So we'll go through all those operations. The first few are very basic Spark operations, like for each map and all those things that you might know if you already do Spark. But then we have some specific HBase operations, the bulk load thin rows, and so on. Ted talked about that. We'll go to the examples. And one important comment at the bottom, this is pretty new, okay? So sometimes we are missing one version of the API. Sometimes we don't have the Java version of it. Sometimes we don't have the Scala version of it. So take a look. If it's not there, open a Jira, and Ted will fix that. Thanks for that. So first one, and this is very big, okay? This is a Foreach partition. It will be the same thing for the map. It will be the same thing for all the basic Spark operations. What we do, instead of doing just for each partition, we do HBase for each partition. And the only difference here is that we get the connection. And that's all the magic that we need, because from the connection, we can get a mutator, and we can just put whatever you want. So imagine you have an RDD, which is a file, and you just want to pass this file and put some of the content to HBase. Then you will do your mutations here, your puts or your increment, whatever you want, that will go into HBase. Very simple. But you can also have something like a text file that you want to store as a Packer file. And here, instead of doing a mutation, you get a connection to your table, and then you do a lookup, you do enrichment, and then you write that into a Packer file. So you will do a transformation of a text file to a Packer file with a lookup to HBase just with those few lines. Very simple. This is the same thing in Java, just to show you that Scala and Java are almost the same length here, like same logic. We get, again, the connection, that we can get the mutator from the connection. We do the same operation. So very, very similar for the two. Map partition, I will skip this one, because it's just another Spark code. So it's a different kind of iterating over the RDD. So again, we iterate over the RDD. And same kind of concept. We can get the table from the connection, and then we will do a different iteration of the Spark data set. So that one is the one why I said you don't always have Scala and Java for the two. This one, you don't have the Java version for the bulk load. You have only the Scala version, and you have a Jira open, which is assigned to your name. Yeah, I did it. To implement the Java version. So what we do here, and you will see it's very, very simple. This is just the loading of the H file. So we can ignore those two lines. All of this here is doing a complete processing of RDD to create H files. Just with that. So simple. The only thing we need to provide to this call is a function here which will transform your data on one side to an iterator for the output. And that's all what you have to do. You have an RDD somewhere, process your RDD, generate your iterator, and then you have a bulk load into HBase. It's so simple. It's very efficient because it's in Spark mode. It's very, very efficient, very simple. Basically, my RDD here, I have two. It's a tuple where the first element is my row key. The second one is my column family qualifier and values. I just get them. I transform them into a key value qualifier. Then I have my key value things, and just emit that. That's all. Very simple. Sometimes it seems to be way too simple. There is another example later that you can just cut and paste and test it. It's a complete one. And you will see it works very well, very fast, and very simple. So this one is what Ted said before. There is two bulk loads. This one, for each key, column family, qualifier value, will create 1 and 3 that will bulk load. If you have millions of columns, it's fine because we process each column differently. On this one, what we do, we iterate over all the columns, and for one row, we put all the columns together. If you have millions of columns, don't do that. You will just kill your executor. It would be too much for one executor. It's fine under like 10,000 columns, so you can test that, like maybe 20,000. Try it, depending on the size of value. But this one will be more efficient if you have less columns than the previous version. At the end, it's almost the same thing again. I will emit those family qualifier values, and then at the end, this object, and that's all. And again, you will have to do the 2 lines after that, because this will just create the H files. BulkPut, like there is no magic in that, like the BulkPut on Java, and we can do BulkPut here also. We give all the list of put we want to do, and then we iterate, we emit the put, and then this that will end, at the end we just do a BulkPut, very simple.
One thing to mention.
You have to come here.
So one thing to mention is all of these have been tested at roughly about 30 billion records, and this stuff is going into production, I think, next month for one of my projects. So it's been tested pretty rigorously.
Yeah, I stated. The example after that, which is just a count, I use that on my own project where I have 3 billion web pages indexed on my cluster in my basement because it's Quebec, it's cold, so it will warm my house. So this works very well already today. So you can use that whenever you want. Don't wait for the next release to use it. BulkPut, again, so this is a Scala version. This is a HBase version of the BulkPut. It's a bit similar. The only difference here, this was a text file, so I used RDD as a text file. I split my text file by pipes, and then my first token is my row key, and then I have a column family which is hard-coded, my column qualifier and my value. Just BulkPuts. Bulk deletes, I will go very fast on that. It's the exact same logic as BulkPut at the end. It's like a mutation, same thing. And that one. So that one is an easy example that you can do a cut and paste. So for now, what we have seen is I have RDD, which is a text file, packet file, whatever, or Spark streaming. I process that, and I do HBase operations. But what about the opposite? I want to process an HBase table and do something with that. I want to, like MapReduce. You can do MapReduce on top of an HBase table. You want to do a Spark on top of an HBase table. This is the way to do it. And you will see it's very, very similar to what you do in MapReduce. It's Java code this time. So all the initialization we have seen at the beginning, we are very familiar with that. This again, as we said before, the Java HBaseContext. And then the scan, like for MapReduce, the filters, if you want to have them, like for MapReduce, and then that's all. This is my RDD, which will represent my entire HBase table. One single line, I have my entire table. If you do data.count, it will trigger the executors, will count the lines. As simple as that. So on this RDD, you can do what you want. You can do map partition, you can do reduce by key, you can do whatever you want the same way you will do on another regular RDD. It works like a charm. It's very efficient, like too simple. So that's all for the examples. And then I will let Zhan go on the more detail on what?
DataFrame.
DataFrame. Thanks.
Yes. So far, okay, thank you. Yeah, so far, Ted and JMS are talking about the RDD. Thanks for their work. When we started this project, actually, that at that time, the DataFrame just emerges, I think, in Spark 1.2. Before that is the schema RDD. There's no DataFrame concept. But when we started this project, we already have the DataFrame. In 1.6, again, the Spark have the dataset concept. In Spark 2.0, they have the unification of dataset and the DataFrame. So we can see the trend. When the end user, they try to use the Spark, RDD is the core concept, is the fundamental of the Spark. But for easy to use, a lot of people, they don't know Scala, they only know SQL, and they want to operate on the DataFrame level. Underlying the DataFrame has the Catalyst engine. They help analyze the engine and optimize the query to the underlying DAG, then do the work for the user. The user doesn't need to pay attention to the map, reduce shuffling, all those stuff. That's the reason we started this project. We have the customer. They have a big HBase cluster, but they want to run the data analytical work on top of HBase. But HBase is a key-value store, and it doesn't support the complex SQL query. But Phoenix is another option, yeah, but we are talking Spark here. We convince our customer to the DataFrame. The first thing, we leverage the Spark Catalyst engine for query plan and optimization. Then is a computation engine. The HBase as a fast access key-value store. we implement the standard external data source with built-in HBase filter. The external data source, I think, is introduced in Spark 1.2. We try to get a good trade-off between the performance and the simplicity, because we already have some data source, open source HBase connector available. I would say that it applies some very advanced technique. For example, they have their own optimization engine. They actually put the RDD lineage and ship to the region server. Also use the coprocessor to do all those queries. We don't want to do that because it's very hard to maintain. If you are familiar with the Spark community, it's evolving very, very fast. If we touch the Spark core code, then every release is very painful to upgrade this code base. So our high performance mainly achieved by the data locality. We try to bring the computation to the region server in the same host. Then partition pruning. For example, if we have a table, they have multiple regions, but only part of its regions host the data. We don't want to scan all the region in the region server. We only want to scan the region that hosting the data we request. Then for column pruning, typically the HBase table may have hundreds or thousands columns, but the region server, we want the region server only return us the column we requested instead of the whole table. Then predicate push down. And we use a Spark HBase built-in filter, so the region server can filter out all the data that doesn't meet our requirements. That also reduces the network overhead. So as a result, we implement a full-fledged data frame on top of HBase, because it's a standard Spark data frame. So after you get the data frame, it has nothing to do with the HBase. You can use any Spark standard data frame API to do the Spark SQL, or to do the integrated language query. Also, we try to avoid any encoding, decoding. After when we try to migrate our code to the HBase, we got some good feedback from the community. Actually, now we try to make this as a plugin for the encoder and the decoder. But currently, the version can just run on top of the HBase table with the Java primitive type natively. You don't need to do any coding, decoding, encoding for your HBase table. Okay. There's some extra feature, the composite key, because for some customer, the HBase is a key value store, and the key part, maybe they have a component key. For example, they may have the name, ID, or timestamp. We support this. Also, the customer requests us, they save the data in some specific format. The Avro format is one of them. Certainly, we can support other format. We can use the series to support that, but currently we can support the Avro format. You specify the Avro schema, then save those data into the HBase key part or value part. We will automatically convert the Avro format to the Spark data type. Yeah, here is how we use our connector. I will go, if we have time, I will go to the implementation part in more detail, but here we first go to the high-level overview. To bring the gap between the Spark and the HBase, we have to define the catalog. This catalog mainly do the mapping between the HBase table and the Spark table. First, which HBase table we want to operate on. Then we define the row key. Then we have a set of columns. These columns doesn't need to include all the HBase table columns. You only define the columns your query needed. But there's one specific column. This one, row key. Row key is is reserved for this catalog definition. All the other column 1 to column 8, you can, this name is a Spark table in HBase. Each column is qualified by the column family and the column qualifier. Then each column has a type, but these are the Spark data type. You also can have complex nested data type supported by Spark. After you define this catalog, you're pretty much done for the user part when you try to run the HBase on top of Spark. This is a major part, you're mapping between the HBase and the Spark. After that, everything is a standard Spark external API framework. This is a very, for example, we have a data, we convert it to a data frame. This data frame follows the catalog definition we already defined. Then we say we use this connector. This is the connector. We use this catalog. This catalog is mapping. Then we do save. Then this data frame will save to the HBase table. Yeah, that's it. You don't need to do any extra work. You have a data frame, no matter it's the external data source, maybe you bring it from Hive, or you maybe bring it from the streaming, you get this data frame. Then you map this data frame through the catalog to the HBase table, then you save it. So you can see pretty much the major work is the catalog definition. The next, how do we, when we save suppose we already have the data in HBase, how do we read the data from HBase as a data frame? It's the same thing. Yeah, this is a facility function. This just a facility function. Yeah. Yes. Okay. Yeah, this you already with this one you return the data frame. After you get this data frame, then you run the language integrity query. Use the standard Spark data frame API. Has nothing to do with from this point. It has nothing to do with HBase anymore. It's just a Spark SQL. The upper example is you operate this table through the data frame. In 2.0 is a do data set. Then if you are not familiar with the data frame, if you are familiar with the SQL, you use the second one. You register this one as table, then you use standard SQL. This you can do select, filtering, join, aggregation, pretty much all the SQL supported by Spark. Okay, do we have enough time? Yeah, this is a high-level usage for the. Since we have some more time, I would go through some more detail. We assume the HBase cluster and the Spark cluster is deployed side by side in the same cluster. That's mainly for the data locality. When the driver receives the query, the Catalyst engine will do the analyzing, optimization, then generate the DAG. But the underlying is the base relation in Spark. We have the condition, for example, where ID less than 5, some condition like that. Based on that, if that ID is a row key, we have a separate a set of range. Define the searching region. Then we use that region to do the intersect with the region server region. Because in HBase, the master table maintain all the starting point and ending point for each region server. Then we do the intersect with the region server start point and the end point. We know exactly in this specific region, do we have the data hosted by that region? suppose we have a 10 region server, but only 4 regions hosting our data. So the driver will send the task only to this 4 executor. This 4 executor will send the request to the region server. This request may be the scan or bulk get. Also, you'll notice that the scan is not a one single scan. The executor may send multiple scan and multiple bulk get concurrently in one region server. But this multiple scan and multiple get is constructed as one task. That is one partition of the RDD. So here, the partition pruning actually do construct the RDD with 4 partitions. Then each partition send the scan and the bulk get to the region server. If you go through the RDD, you will see get preferred location and the get partition. Those information mainly for the data locality and the partition pruning. And also, when we send the task, we also piggyback the predicate to the scan and the bulk get sent to the region server. So the region server can filter out all the columns that does not meet the requirements. This is the status for this Jira. We already have a repo, but hosted not in HBase upstream. But we are in the process, migrate all this code to the HBase trunk. Pretty much most of them already done. Yeah, this is outdated. This one already committed. The major piece left over is the composite key support. Is under active review now. After that, we will do some documentation work. Then this umbrella Jira pretty much cover all the functionality we discussed today. Okay, Ted.
So we didn't add this one slide, but if you're curious later on, come over and say hi to me. I'll be over at the booth for a little bit. What? 5 minutes. I have an example of how to go from HBase with Spark SQL to MLlib in like 5 lines worth of code, right? So you define the table, then you just do a Spark context SQL statement that says select star from table, and then you turn it into vectors, and then you run your k-means. It's that simple, right? So, so since we have 5 minutes, we should open up for questions then. Yeah, I won't go over this. If you're interested in Spark streaming, yeah, let's open up for questions though. Yeah, if you're interested in Spark streaming, I can talk about it later. But essentially, the big thing you can do now with Spark streaming that if you go back in the Lambda paper, the big difference is the Lambda paper talked about doing increments, but with Spark streaming and now the newer frameworks like Flink or even Kafka Streams, that's still young. Because you have the idea of doing update state by key, you can do puts into something like HBase or a system like that. And the idea of doing a put is if you put twice, the value is not going to be double incremented. And it's fairly easy to do now that we have integration with Spark Streaming. So do you guys have any questions?
Yeah, there's a question right here.
Hey, Ted. Just had a quick question on the choice of use of a custom schema rather than the Spark SQL existing schema. Any comments, or is it something that will change?
So
I guess I'm not too sure.
We're using. The only thing you have to add that's different from normal Spark SQL is like he was showing. You have to do a mapping, right? Because HBase does not have columns per table, right? So what you're essentially doing is you're saying to Spark SQL is if you see these columns, map them to these columns in Spark SQL, right? It's just a mapping. So if there's columns that aren't in that mapping, they get ignored. And if those columns are not in the record, they come back as null. But once you make that definition, everything after that is Spark. There's no HBase after that.
Exciting work, guys. We've been rolling our own Spark HBase integration. Good to see something that's more standardized. And a quick question about the scan. How does it compare to if you just use the new Hadoop API and we were reading stuff as we are? There were some issues with like getting one mapper per region and things like that. Is this some enhancements that you've done on this front?
I mean, you can help speak to this, but it's still one scan per region.
Yeah, I can talk about this one if you want. Basically, it depends on how many executors you have configured. Here, it's no more 1-for-1. If you configure 2 executors and you have 20 regions, then each executor will have to deal with 10 regions. But if you have way more executors and less regions, then they will share the work. Basically, Spark will do all the logic behind the scene for you. It's no more a mapping 1-for-1 as we had before.
Okay,
Yeah.
good to know.
Currently,
Thanks.
yeah, is the number of scan is the same. Actually, the number of scan can be much more than the region server, but the task number is the same as the region. One task may consist of multiple scans.
Got it. Thanks.
But it's not impossible to imagine a world where you could do that. It's just that wasn't included in what we did.
Yeah, this is very interesting because we do Flink plus HBase. I do similar thing, connector and the table API. I have 2 questions. So the first question is that, so in Flink, we put all the connectors and those things, table APIs to the Flink libraries. So in this case, why do we deliver the Spark specific into the HBase? The second question is you mentioned for the Spark streaming, so you want to do the local thing. So let's say you have 1 key per region. What about if I want to fetching 2 keys and in different regions? Is it going to be shuffled? How do you manage this in this library?
So what was the first question one more time?
So why do we put the Spark-related library APIs into the HBase domain, the code base? Why do we not put this into the Spark?
Oh,
'Cause,
why is
Spark
Spark in HBase? Why is we include it?
Right.
So there was a huge argument for a long time. So when I originally wrote this, I had asked the Spark committers, and they said no. And then I had asked the HBase committers, and they said no. So for a year, it lived in my GitHub, right? And then HBase, I think, had a change of thought, and I think it was a couple of reasons. One is Cassandra started really getting aggressive with Spark, and the other one is I think people recognized that MapReduce was dying or dead, right? And HBase included the libraries for MapReduce. So, and you've heard talks about people separating HBase from HDFS. So in that sense, MapReduce was already a foreign API, right? So if we're going to support foreign executor APIs, why not support the one that everyone's actually using? So that was the argument to put Spark in there. And in theory, and I don't think this is a far-fetched concept, the Spark APIs should get more love going forward than the MapReduce APIs. And the MapReduce APIs eventually, I don't think it's hard to imagine, get deprecated. And, is that fair?
Yeah,
Yep.
actually, that's another reason why it doesn't go into the Spark. If you follow the Spark, you will see actually Spark now try to move all the unrelated core stuff out of Spark code base.
Yeah. What was the second question was?
Different keys in different regions. How do you manage this in your mapping things?
So it depends on what you're doing, right? There's lots of techniques, right? If you're just doing like a put, if the keys go to different regions, it's just a regular put, right? It'll go over the wire to the region, and the executor is totally separate from the region in terms of locality. And just, when you're using he's asking, is the execution near the data? If you're using, it's same as MapReduce. If you're reading from HBase with like Spark SQL, or if you're reading from HBase with the RDD, the HBase RDD, you read locally, right? You read locally first. But just like MapReduce, if you're doing puts on the reduce side, you can't guarantee locality, right?
Another example, same thing. If you are processing an RDD, which is a file, and you do a lookup, which is a get, then your executor might not run in the same server as the region which is hosting your lookup. Like executor might be somewhere else, and you will do a network lookup to get the information because your file and your region might not be in the same server physically.
But on that note, there's a nifty little trick that I haven't seen documented too much, but I've used it several times. Locality is important, but if you can't get locality, let's say on the reduce side you cannot get locality, it's still beneficial to get to be partitioned the same way the region servers are partitioned. So I have found if you're doing bulk puts, not bulk load, just bulk puts, if you did a shuffle beforehand on the same splits as the region, when you do a bulk put and you're doing like 1,000 at a time, instead of getting spread out across all your regions, so it's kind of like this broadcast where actually a single record gets to each region server, if you do the pre-shuffle, then all 1,000 goes to the same region server, and you get a lot more efficiency in terms of your write patterns. But you don't get locality.
So we're actually out of time. So this concludes this track. Thank you very much.